All right. So that fund sheet, as I was telling Brian, that fund sheet is legal size now, 30% more fun. You'll love it. It's super enjoyable. That's how much it is. That was in a good way. I want to get questions on 58 and 59 at home.
I'm sorry, I have a depression large amount of questions.
Oh, that's okay. I'm glad you're here to ask the questions. Pete will be here to answer. Hey, Pete's here. Yay! One of the few people that speak in the class. Thank goodness. Used to. You asked.
Useful, but like.
Lord, well, you're brilliant. You've never seen it. What the heck?
She's a bummer.
Here we go. All right.
Is this enough room?
Don't do it for fun. Guys.
You should. Okay, questions on 58.
10, 16, 21,
10,
22,
16, 21, 22,
20,
1, did you say? 20,
23.
23, did you say 20 or no?
No,
Okay,
and then like all the replacements.
on all the replacements.
Specifically, like the final replacement.
Yeah.
Let's do that. Okay. Did we get through the package problem all the way, or not yet?
We didn't even do any of it.
We didn't even start it? Oh, okay, cool. All right. I'll do the calculator work, although if you want to put it in your calculator, so be it. The idea is that you are in a UPS facility, you report to work at 7 a.m., and there are 400 packages in a place that need to be sorted. Okay? I worked at UPS in college, and so packages come in from planes from all over the country, and they come in on the conveyor belt, and you put them on trucks to certain areas of the city. All right? So they're coming in at this rate, and you're sorting them at 750 packages per hour, and you're calling it. All right? So there's an in rate and an out rate, and you have a starting point. So if I were to talk about the overall rate of change, then I could say it's a rate of change, so I could think of it as a derivative of the number of packages, n prime at t or d n dt. Change in the number of packages with time. What are the two things that contribute to the rate of change in the number of packages? All right, I talked so much that you probably stopped listening after about 30 seconds of it.
Packages and how much?
Okay, how much I don't care about, just rate of change. What if that's how many come in? Read the problem again, please. I will stop talking and have you read. What represents the rate at which the number of
What
packages?
represents the percent?
P. P is the rate at which packages come in. It's they arrive at a rate of. So this is the rate in. What is the rate out? R. They send them out at R of T. Now because they're sending them out, that R is decreasing the number of packages. So you can think of that as the net rate of change. In versus out, right? If you were to graph this, the original graph is 1,000 plus 420 sine. I wish I was 1,420. I don't know what I was thinking. So 250 plus. I know. I have no idea.
Why would you regret that?
Because it's stupid. Then I know I get one. At any rate, so the net rate is 250 plus. That would be a center line of 250, and because the amplitude is 420, it would take it up to 670 and down into negative territory, and then it would be shifted right to actually. So overall, I think the graph looked like this. Now that is not drawn to scale. Please keep that in mind as we go through this. Okay, now then, if this is the rate of change in the number of packages, then tell me what's going on in this time frame with respect to the number of packages in the facility. It's decreasing. because the rate of change is negative. In this case, it's increasing, and then it's decreasing. All right? So in order to find when the number of packages is increasing, what would you do in your calculator, which I've already done to some extent for us? What would you have to do in your calculator? Find the zeros. I would need to know where the starting and ending point of the increasing region is. Yes?
Oh, wait. I was thinking you were subtracting 400 from 750 and then understand where you got 250 and 350. I think you did that.
Okay, cool. So I can't remember exactly. Just a second, let me recall the zeros. I found them, but then I forgot to store them. I think one was at 0.48. Come on, baby. Be good to me. Just be patient. 0.9852 is this point. 0.9852 and so that's A and 8.0147. Okay, now I say that's when it's increasing. Why do I say that? Or why do you say that? Because of the x-axis, because end time is positive. You could also say, in terms of how the rates compare, what's going on with the rates in that section? What do the rates compare, P and R? In that case, the number of packages increasing because P, the rate in, is greater than R, the rate out. You'll see that justified one of those two ways, all right? So far, so good? All right, then. Find all times when the number of packages is at a relative min. Would you consider this that you'd have a minimum at the end of a decreasing interval? So I know that up to 0.985, the amount of packages was decreasing. So if the number of packages is decreasing up to that point, isn't that a min, yeah? You with me?
Yep.
Now that's a logical one because it's a rate of change going negative to positive. Is there any other?
You said the question like that, but it probably is.
There is, okay. Again, don't just get locked into negative to positive because that's only in the inside of the time frame. Think of it more like there's a min at the end of any decreasing interval. So where else is there an end to a decreasing interval? At the end, at time 10. That also is a minimum, okay? Because it decreased up to that point. So it would be at time equal 0.985 and 10 because the amount of packages is decreasing up to those times. Endpoints then are going to require more analysis than just negative to positive interior points. Okay, so it says find the amount of packages at the relative min and the endpoints using the fundamental theorem of calculus. So the question really is, I want to know what is the absolute minimum number of packages in the facility during the course of the day. There really are only two candidates. It's increasing for all these times, so as far as the minimum of that region, it would have to be there. And then I know that's a candidate because it decreased up to that point. So it's really just a fight between the two possible candidates. I need to figure out, of those two, which has the lowest number of packages. So how do I find the number of packages at time 985?
Integrate the original part.
Yeah. So you integrate, if I integrate, you'll probably skip this step. If I integrate the total rate of change, then wouldn't that give me change from the starting point up to some point in time? And I want to talk about what's happened up to 0.985. And that would be the number of packages, the difference in the number of packages, or the change in the number of packages. So if I want the number at 0.985, I would need to take the starting amount plus the change in the amount, right? So if I throw that into my calculator, starting amount plus change, what was the starting amount? 400 plus 902 A 2 I get roughly 315.7516 or 316 to the nearest packages. Does that make sense that that 316, does that make sense in terms of how it relates to 400? Yeah, over that time frame I decrease so that I am getting a number less than 400 is totally logical. Yeah. Now, if I, yes?
Okay, so for the 316, wouldn't you round down instead of up? Because
You hadn't processed a full package there?
yeah.
Good question. That would be sound. At least 350. Sure. On the AP test, they would say round to the nearest or round down. That's fine. I agree. Now, question. If my picture were drawn to scale, could you tell me if this guy is going to be greater or less than that guy? If this was drawn to scale, then this region of increase versus that region of decrease, which area is bigger? The increase. Okay, so that would tell me that this is probably more or less than 360. More, because it increased more than it decreased, so I would imagine that endpoint is more than 316. But it's not drawn to scale, so let's find it and be sure. You shouldn't trust your eyes, you should trust your analysis. So I need to find the number at 10. Using the same kind of fundamental theorem approach, how would you find the number of packages at time 10? Number at 0, which was 400, plus change, which is from 0 to 10 of the integral p minus r. And that, I could just recall that same integral, type over a with 10, and I get 2,900. I don't remember that being that clean, but okay. Okay, so from that, the absolute minimum number of packages, there were only two candidates for what the min would be. One came out to be roughly 315, the other 2,900. So the absolute minimum over the course of the day is definitely 315 packages. Agree? All right. The replacement here. This actually was in error. This did not communicate what I wanted to, so can I change this really quick to x to the 2/3? I intended to make the seagull function, not the cube of the square root function. The point I'm trying to get across to you is this. There are two tests for extrema, the first derivative test and the second derivative test. There are two types of extrema, this kind of or this kind. Okay? Now, for a minimum like this, I could use the first derivative test because it would work to say the first derivative goes negative to positive. So the first derivative test works. The second derivative test also would work because I could find where the graph goes flat and that the graph is concave up, and the second derivative test also works. If, however, you're looking at a critical number where the derivative does not exist, remember we can have MIMs where either the derivative is 0 or it does not exist, well, the first derivative test would still show that the slopes go negative then positive, so the first derivative test works again. In fact, the first derivative test always works. Always. The second derivative test, however, fails because the second derivative test depends on finding a horizontal tangent. There isn't a horizontal tangent there because the derivative is not 0, it's dne there. Furthermore, if the first derivative test doesn't exist there, then the second derivative also won't, and I can't test the sign. So the second derivative fails at such a case. And in those cases, you have to go back and say, I guess I'll use the first derivative test. That's what I'm trying to get across to you here, what that looks like when you go to try and use a second derivative test. If I use, again, was supposed to be x to the 2/3. The derivative here is 2/3 x to the negative 1/3, or 2 over 3 cube roots of x. The critical numbers are where this is 0 or does not exist, and that is at x equals 0. Now the first derivative test works because less than 0 at a negative, this would be negative, and after 0 positive, so I could conclude that f has a min at x equals 0 because the first derivative goes negative to positive. First derivative test works. Second derivative test will fail because, first of all, the first derivative is not equal to 0 anywhere, so there's no horizontal tangent. And furthermore, the second derivative doesn't exist, so the second derivative test altogether just falls apart, and it's only the first derivative test that works. So, if I gave you a picture like this, which test or tests could you use to identify extrema at A? First and second. What about a B? First one. Okay? Okay. Is that all the replace? 21, 23. There we are. 21 and 23. 21. Oh, yeah. Okay. Oops. 21. I did one like this in your notes, but that said, maybe either it didn't make sense or it was still difficult. I don't know. But it says they can sell, the number you can sell is 120 if the price is $10. And the number you can sell decreases by 20. So, for example, that might be 100. If they decrease the, get that, sorry, just a second. If they decrease the price by $1, they sell 20 more units. So they might sell 140 if they drop the price by $1 to 9. I could keep going and do lots of cases, but that's true. What price will maximize revenue? So, this is an optimization problem. First, identify what you're trying to do, and then get an equation for it. What's an equation for revenue? What is it? NP, yeah. How many I sell times the price of each gives me total revenue. Now what do? Don't want to take the derivative yet because there are 3 variables. What else can I do? So you want to get another equation. What's another relationship from N to P? All this stuff is relating N to P. Yeah. What's the equation relating all this stuff? I just see a bunch of numbers. What kind of relationship is in there? Mathematically, what kind of relationship is going on there? All right, so I agree there's an inverse relationship in that one, as one grows, the other shrinks. 9, 140. I guess I could go 8 and 60. It's always the same change. So what kind of relationship? Linear, with negative slope. So what's an equation of that NP relationship? What's the slope? Negative 1 over 20 or negative 20 over 1? Negative 20 over 1, okay. Point slope or slope intercept? I don't know what the y-intercept is. I guess I could keep tracing back until I get to 0, but let's use point slope. Give me a point slope equation relating these two. Y minus. Okay. Give me what's y in this case? What variable is y? Sorry. N minus 120, I like it, equals negative 20 times p minus 10. Okay. Now, I'm going to use that, so I probably want to solve for that. So I'm going to solve, oops, and get a final something like 320 minus negative 20p. So revenue then is 320p minus 20p squared. Nice. Now I can maximize revenue. If I want to know where R prime goes, if I want a maximum, I want where R prime goes, plus minus. So R prime then is 320 minus 40p. This is 0 at 8, and before 8, I am looking at a positive, and after 8, I'm looking at an 8. So that is indeed a max. Finally, just answer the question. Is it what price, or what's the maximum revenue? They say what price, so I conclude the price is that maximizes revenue is $8. Cool. And then what else? 23. Okay. 23. F of x equals x to the fourth minus x cubed. Finally, where the extreme occur, which is to say, give the x, justify the second derivative test. So, if I take the first derivative, it looks like that. And that then is x squared. This equals 0 at x equals 0 and 3/4. All right? That's places where the graph goes flat. Now, I go on and say, what's happening about the concavity at those flat spots? The second derivative is 12x squared minus 6x. Shoot. F double at 0 is 0. So that implies that there's no concavity measured to that, so the second derivative test fails here because there's no sign. I'll have to get that one with the first derivative test. What about F double at 3/4? That's 4 times 3/4 cubed minus 3 times 3/4 squared. That is something like 27 over. Is that positive? Can you just see if that's positive or negative? Oh, I am not putting it into the second derivative, am I? I just used the first derivative, didn't I, dummy? Sorry. Into the first derivative, let's go with 6x. 2x minus 1, geez, please. Okay, so I will be looking at 6 times 3/4, which is surely positive. 2 times 3/4 minus 1, surely positive. So this is greater than 0, implying the curve is flat and concave up. Down? Up, right?
It is.
Okay, and so we have a min. F has min. at x equal 3/4 because you need to cite two pieces of evidence, the flat and the concavity. So because f prime at 3/4 is 0, and f double at 3/4 is positive. As far as the other test, at 0, if I go back and test the first derivative at 0, before it's positive, negative, and after it's positive, I should go up to 3/4. Positive, negative, then it implies basically there's no sign change at 0 because it's square is what I'm saying. So what's going on at 0? Min, max, or neither? It was decreasing before 0, then it went flat, and then it went back to decreasing. So there is no extreme at 0. There's only an extreme at 3/4. Cool? All right, then let's go on to any other questions here? 10, 16. Wow, that's a lot. 10. Okay, I can say that 10 helps if you draw a little picture. If on -1 to 2, the maximum value of the function is 10, then as far as the area under the curve, the area under the curve must be less than that box there. Whatever f is, if it achieves the max somewhere in there, I know that the integral from -1 to 2 must be less than that enclosing blue rectangle, so must be less than 30. On the same token, if it has a minimum of, where I lost my point, -5, then the least possible value the integral could be is bound below by 3 by -5, so 15, -15. So the integral value has to be between -15 and 30, and that's where I'll use pictures there, my point. 16. Is 16 still a question?
Yeah.
16. Is it, why doesn't my answer look like theirs? Is that the problem? Because they often
No,
do.
it's something I got it violently wrong. I would definitely wrong.
Violently wrong. Wow. Violently wrong. Don't just get it wrong, get it violently. I like that. So dramatic. Cosine AX. Okay, so is this a coefficient or do I need to use a product rule, I guess is what I'm saying? No, it's just coefficient. So 1 over log 2, and the derivative of that is derivative of the outside, so the derivative of natural log times the derivative of the inside, so something like 2x plus 3. Do you agree with that first derivative? Okay. Minus, did you use the quotient rule here? Yes, maybe? Or did you, yeah, let's just go with quotient rule. Low d high is cosine of x. Minus high d low. Derivative of cosine of ax, check your quotient or your chain rule. Derivative of cosine is negative sine ax. But then times derivative of ax is a over the square of what's below. And as far as I'm concerned, I'm done. That's it. I don't care how they clean theirs up. I'm stopping. That's it. All right. 21. Yeah.
The AP test is okay to leave it like that.
They will never get something that complicated, but there are times where you have to find the equivalent, but it won't be that early. 21.
We did 21.
Oh,
We did
oh,
23.
sorry. So we're good from there? 1,
We need 22.
22 is different, okay. 22 is you either recognize it or you don't kind of question. What is the, forget the 4/9. What does this graph look like? Circle with a radius of 3. Then the question is, all right, what part of the circle? Tell me first of all why it's top half only. Because it's positive. Tell me why it's right side only. Because it's 0 to 3. The limits of integration are 0 to 3. So it feels like the integral is just a fourth of a circle. The 4/9 comes along for the ride, so 1/4 pi r squared times that 4/9. The radius is 3. Check, check, check. All right. What about 1? Is that a question still?
No.
You're good?
What was the answer to one?
I had, what did I get for it? 58, 1. I got 8. Should we talk about it, or no, you're good?
It's probably just an arithmetic thing, so we can.
What did you get for a critical number? Did you get root 2 for a critical number? Or, oh, okay. So just to get you to see where you're, I have that the area was 4xy, which I think from talking to you yesterday we agreed on. That the x, by virtue of the circle, if the circle is x squared plus y squared equals 4, then an xy relationship is just that y is root 4 minus x squared. So this became 4x root 4 minus x squared. Wait. The derivative was first stays the same, derivative of the second times negative 2x plus 4 root 4 minus x squared. Yes? Okay, I took out a 2, and so with a common denominator of root 4 minus x squared, this first one was negative 4x squared, and this one became 4 minus x squared. That's where the algebra errors usually come. Thank you. Is that, are we stopping there for you now? So my numerator became 16 minus 8x squared. Okay, that's what I got root 2 for the x and the area with it. Okay, with 59 going on. 59. Shall we talk questions on 25? 25. 25 is a butt kicker. 1.
4. What were you supposed to do for 8? You just not
1, 4, not 8. What about 8?
What did you want us to do for it?
I wanted you to just do the problem, forget that stuff I added. So just do 8. The last one, the velocity, last problem. That was a good one. 25 was a good one.
I have a quick question on G. Are we allowed to use the calculator?
You may use a calculator for 1 and 2 on the front sheet.
Okay. Thank you.
In other places, I think I specified, but I know I did.
Just want to make sure.
4?
4.
Cool, cool. All right. All right. Here we go. 25 was a humdinger. $59.25. You're given this rational function. x squared plus 2x minus 3 over x squared plus bx something else. And down plus 4. And it's supposed to be continuous. This one was tough. If it's continuous, then what two types of discontinuity need to be excluded? What kind of holes? Cannot have holes. What else? What other types of discontinuity does a rational function have? Anybody? That's a derivative issue. Vertical asymptotes. Okay? This is a rational function. It could have vertical asymptotes, could have holes, but it says it doesn't. So what does B have to be in order to affect that? So let's start with holes. If it's no holes, then what cannot be happening? What causes a hole in a rational function? You get a hole if what? It cancels that. There's a common zero. Okay? If there's no holes, then there's no common zeros. Now, I don't know about that, but I guess I could look at the top and say what makes the top 0. And it seems like the top is 0 if x equals -3 or x equals +1. So I guess I need to ensure that when x is -3, the bottom is not 0, so I don't get a hole. So if the bottom is not 0 at x equal -3, then what does that tell me? That when I put -3 in, it's not 0. So that would mean 9 plus 9 minus 3b plus 4 is not 0. So yeah, B is definitely not 13/30, yeah? Because if that's the case, then I have a hole. What else? Well, at x equal 1, I know the top is 0, so I can not have the bottom 0 if x equals 1. That would imply that 1 plus b plus 4 is not 0, so b is not -5. Okay, so as long as I exclude those two outcomes, then I won't have a hole problem. Now I need to deal with the vertical asymptote problem. Vertical asymptote problem happens if there are no vertical asymptotes, then I have to make sure that there is no what? How do you get a vertical asymptote? 0 in the denominator, okay? So I cannot have the denominator equal 0. So the denominator cannot equal 0. Cool. So you get, quadratic, yeah. So by quadratic, that means that -b plus or minus b squared minus 4ac over 2a is never has any solutions, has no solutions. In what case would this not have any solution? In the quadratic formula, you get no real solutions. I'll say real to help you. No real solutions if if the inside is negative. Okay, so this is going to not have zeros if b squared minus 4, 1, 4 is negative, which implies b squared is less than 16. Now that would mean b is less than 4 on the positive side, and what about on the negative side? Greater than -4. Another way to write that, besides b is between -4 and 4 with absolute value, that means the absolute value of b is less than 4. Last but not least, let's check for redundancy here. I say over here that b can't be 4 1/3. and I can't be -5. Do I really need to say, hey, b is less than 4, and by the way, it's not 4 1/3? That's kind of stupid, yeah? Likewise, if I say b is greater than -4, then I don't need to say b is not -5. So this is ample, and that's what tells me the solution. Okay?
I don't need 4 anymore.
Don't need 4 anymore. Cool. All right, how about 1? 1, yes?
Yeah.
Yeah. I had a hard time getting the boxes with lids are much harder. Okie dokie. This should be the same as this. Okay, can you picture it okay, or do we need to talk about this? This, you can picture it, cool. So this piece will be a dimension I need to account for. That's the hardest piece. This whole thing was 8. Notice that among the 4 chunks, it's 2 identical base and tops and 2 sides. So I could look at a half the picture and say this is 4. Now if this then is some unknown size of a square being cut out, then what is this side? 4 minus 6. Okay, cool. Now, if this was 4, and we cut out x from both sides, then this piece that will remain for my base is 4 minus 2x. And then the height is an issue also. That'll be x. So in the end, volume is 4 minus x, 4 minus 2x, and x. Which, before I do my calculus, I'd probably distribute 16 minus 8x minus 4x, so minus 12x, plus 2x squared, all times x. So maybe a nice 16x. Let's put it in descending order even. It's just super clean. 2x cubed minus 12x squared plus 16x, prime where b prime goes positive to negative. If that wasn't hard enough, you'll find that v prime is a quadratic that doesn't factor, so you'll have to use the formula to use.
I got it.
Okay.
It was the very first one I did was wrong.
Yeah, the picture, the lid makes things make things hard. All right.
Hey, wait, can you keep going on that one? I missed something else.
So I had a v prime of 6x squared minus 24x plus 16. I dumped a 2, which wouldn't affect a sign test or anything like that. So 3x squared minus 12x plus 8. Try as I might, I could not get that to factor. Not everything does. So I went to quadratic formula. X is 12 plus or minus 144 minus 3, 3, 4, 3, 8. Over 2 times 3. That's 12 over 6 plus or minus. That's, what? Let's say 32 times 3, 96, 48, square root of 48 over 6. 2 plus or minus, that's 4 root 3 over 6. 2 plus 2 root 3 over 3, or 2 minus 2 root 3 over 3. I don't want to sign test and all that stuff. I just know that a cube looks like this, so I get the max at the lesser critical number. Which one is the lesser critical number? Okay, so answer the question based on that line. Okay, and then the velocity question. Here we go. Okay, so this is an x to the 4th shaped graph, yes? With zeros at 0, 2, and 4, and it bumps 4. Hopefully you have the graph correctly shown. By each of the regions enclosed by the x, didn't word this very well. By each of the, yeah, I should have said, next to each of the regions enclosed by the x-axis in the curve, on 0 to 5, so I need to enclose here, state if the car is moving right or left. Here's a region enclosed by the x-axis in the curve. Is the curve moving, or is the car moving right or left? Left, because velocity is negative. Right. And it stops momentarily at 4, but then it goes back to moving right. All right, then. Here is where I might have got you. We'll see. Did I get you or not? Give the 2 times on 0 to 5 where the car might be farthest right. Give me 1. 0. Wow, you are good, sir. Time equals 0. And give me another. Time equal 5. Now, time equal 5 makes a whole lot of sense to me. It might be farthest right there because it was moving right up to that point and up to 4 and then kept moving right. So it's very logical to me that it might be farthest right at time 5 because that's the end of a rightward movement. Why times 0? Yeah, think about where at time 0 it's here, and from there it moved left. So this is also a possible farthest right tau element because it moved left after that, or decreased in position from there. In order to compare which one was most far right, I would have to figure out where was it there versus where was it there, or did it move right enough to overcome the movement left? Keep in mind, my picture is in no way drawn to scale, so don't trust your eyes on the area. So if I want to know when is the car furthest right of where it started at time 0, I guess I could just say position at 0 is what it is. I don't know what it is. I guess I'll just leave it at that. But to compare, I need position at time 5. How do you find position at time 5? An integral to get the change in position from 0 to 5, and then I would have to add that to where it was at time 0. This ending position would be starting position plus changing position, yeah? If you threw that into your calculator, I get something like x initial, I still don't know, but this is negative 4.166. So what does that imply? Yeah, at time 5, it's where it was at time 0 minus, so left of that 4 units. So its position at time 5 is 4 units left of where it was at position at time 0. So when is it absolutely farthest at the right? Yes. Oh, yes. That's why I was wondering why you were getting Swedish on me. Go ahead. Yes. It is Veterans Day this weekend. By the way, you should go to the parade if you can honor your veterans tomorrow. I know I will go. Farthest right at time 0. Other questions on 59? No? Okay, 58, 59 are due today. We are caught up.
6 times 12, 72.
What's that? What'd you say?
6 times 12 is 72.
Oh, yes, correct. I concur, 100%. Brian asked if you could use your calculator, and yes, the calculator is okay on 1 and 2. In fact, just use your calculator anytime the question doesn't say do not use your calculator.
Good morning, Evelyn, faculty, staff, and students. Today, on November 10th, we are recognizing Veterans Day, which impacts us tomorrow on November 11th. Veterans Day is the day where we have a chance to honor military veterans, aligned with Armistice Day, which was the official day that ended the war in World War I, on the 11th day of November at 11 a.m. in 1918. Since 1945, Americans have recognized Veterans Day, and in keeping with that federal holiday, we hope to recognize, honor, and to thank all veterans of the United States military today and tomorrow. At this time, teachers, if you could open your doors and allow students to enter the hall to hear the Star Spangled Banner performed by our concert choir under the direction of Devlin Sr. First Lady.
I can't hear that here, so I'll go down
I'm not going. You don't have to go, Victoria.
Okay, then I'm not going.
You're too tired.
Finishing the prom set from last
Even
night.
here.
What?
Even here.
There's no point in going out there.
No. It's being a walk down.
Just the other flag. Got him.
Yeah.
I'll try to sing it for you, Brian, if you want me to.
Diva, yes.
Where are we at, Nick? I don't even know what I did wrong, but something went terribly sideways. I pledge allegiance, let's just do a pledge allegiance, yeah.
Thank you, concert choir, for your wonderful performance. Today, boys and men will meet today in our room for the preparation for capture the flag. As we're a part of boys and
When they come back,
On Monday, Madison University of Colorado will be here for a college visit during 7th hour. They have a brand new 35-foot climbing wall and a club climbing team. Check them out.
Yeah.
today there will be a girls' night evening. Come to your concerts and make friends bracelets.
Attention Calligraphy Club. Today's club will be for regular attending members only.
Senior high students, Spanish Club high school students come to the students' room today for churros and games.
Churros.
That's right. The girls' volleyball varsity team is on their way to the state playoffs. They are scheduled to play at the Denver Coliseum tonight. Be there to cheer on their varsity girls. Go Jags.
No, that was just for part A. For part B, if I wanted to see anything, I'd have to say just from 0 up to 80.2.
Oh, no, I'm talking, I'm just
Oh,
verifying that one.
Oh, I see.
Yeah.
This is the amount pumped out, but you would do that in conjunction with the 100 gallons to start. Oh, ah, dang it. That would be negative. Sorry, if you've done number 1, part 2, it should be more like there was 200 gallons in the tank at times 0, sorry. Otherwise it doesn't work,
Okay.
sorry. So,
So it'd be 200 minus that.
200 minus that.
Okay.
So, yeah.
Alright. It's okay. Thank you.
That's a really long.
This weekend is gonna suck.
That's not a great
I have to
comment.
write 2 lessons. I have to write my entire terms. I haven't done any research. Yeah,
I've got, so
I'll study.
I'm ready like probably so one right? I have maybe evidence for them. The other half I just like bullet
In English, what's that? That's all we're all like, I have to write my entire.
If didn't slip all of it. I don't have your yeah, no, if you guys missed Friday, you're gonna be emailing by the time you're
God bless America, land of